Welcome to this afternoon's webinar. My name is Alec McCutcheon from Unicom. We're delighted to welcome today's presenter, who is Christopher Osborne from Booking.com. Chris is going to be speaking this afternoon on big data for real people in real time. And in fact, in just a couple of weeks, he's literally going to be speaking in real time at our conference, which is on 5th of December, Big Data in the Context of Financial Analytics and Social Media. So what I'll do now, I'll hand over to Chris, and there'll be some time for questions at the end of the webinar. And I hope you enjoy it. Thank you.
Okay, good afternoon, everyone. So a very, very brief introduction about myself. I started off as what is now termed a data scientist, and went from there to starting to build my own products, and have been through various startups. And I'm now in Booking.com, which is very, very large in terms of funneling people through to the right booking properties that they might want to stay in a hotel. We deal with huge amounts of data every day in real time, constantly looking at how we can apply data science, statistical analysis to better present information to customers. And ultimately for us, of course, the gain is for us, the more people we get to the right property, the better we do as a company. But my roots are kind of back in maps and geo. It's a very interesting field. It has an interesting play in the data science space because there's a more heavy emphasis on visualization, which can be overlooked in the world of big data and data science. But before I get into that, there is going to be quite a lot of visualization examples and how to turn very complex issues into something that real people understand. By real people, I'm talking about the average person, people unlike me who don't have degrees in computer science, haven't spent years mining data, haven't spent, or in fact have no interest or very little interest in kind of digging down into data. It's one of the big myths of data science and what we're doing now, that people actually really want to dig into data, and it's just simply not true. People want to have information presented them easily, things that they can glance at, things that they can make a very quick decision with, and that's part of what all Booking.com is about. So that's I'd just like to put that out there now as one of these big myths that people actually really want to dive into data. It's just not true in terms of most common use cases in real day. I also want to talk about the origins of data science, the origins of big data, because we live in a world where a lot changes very fast, and we get very excited. And I'm sure a lot of people are interested in big data now because they're assigning budget to it. They're kicking off new projects internally. They're also very new. So I just want to do a quick recap of the history to try and put this into context. This is the seminal paper from 2004. Not going to go too much into the detail, but MapReduce is the kind of the foundations of the building blocks of what big data is today. It's breaking large complex problems into smaller parts and then pulling them back together and doing it all very quickly. That was the seminal paper which started where we are today. It was an internal system in Google. And in 2005, Hadoop came along, which opened up this technology to everybody else, which is caused this massive interest and this massive uptake of interest in it. To delve into some of the details without going too far, this is kind of the classic description from the Google paper, whereby you have a worker, programmers, you have data, and a worker, or a computer, as this really is, it's a processing unit, splits a large complex task on the left into a large number of smaller tasks, which are then mapped, that's the map function, mapped to many computers. Computers do their processing, they pass it on to the final stage, where you can see two workers again, or two computers, which reduce it. They aggregate or summarize all those answers into one output. So that's map and reduce. I hope you're still with me. And this is what MapReduce used to look like. This is a data center in 1943. This is the NASA one, and you can see computers at work. And in 1943, a computer was a person. It was somebody who computed tables or computed outputs. And also in 1943, we had the gentleman Richard Feynman, If you're interested in science, philosophy, I highly recommend looking into what he has to say. And if you read his description, also the context, he was working in Los Alamos, which is on Project Manhattan, essentially producing the first atom bomb, and did a very, very complex calculation and problem to solve. And his quote at the time was, set up a room with girls in it. Each one had a marchant, that's a little calculator. One was the multiplier, another was the adder. This one would cube, and all they would do is cube it and send it to the next one. So exactly the same principle of big data, MapReduce, but back in 1943 with human computers. You took a very large, complex problem, you broke it down into a subset of functions and analysis. You had them all there, and then at the end you reduced them into one answer. And that was what enabled America to actually produce the atom bomb in the time they were able to do it. And just for a little bit more history, that's the original, the very first punch card, IBM punch card machine, was being used on MapReduce tasks to perform big data. So, I hope that kind of dispels this myth that we're doing something new here. It's the founding principles of what we're doing here today are exactly the same work. And Richard Feynman is a very interesting scientist and philosopher. Talks all about science, understanding, and uncertainty. And all these principles still apply today. Data science is about testing hypotheses, about creating a hypothesis, testing it, performing a lot of statistical analysis, and then you have an answer. And it's not necessarily 100%, but big data is about reducing uncertainty so that we can be a lot more clear, a lot more understanding of what is going on, what are driving people to do things. And the drivers for that today are the web, huge amounts of data, which we can now process at very high volume. A huge increase in the number of personal data, what we're looking at online, how we're interacting with people. All these previous interactions, such as my current booking a hotel, might once have been done physically, where you entered a travel agent. It might then have been over the telephone or by post. And now finally, all these transactions and interactions are happening online, and all the data is being stored, and we can process it, and we have the volume and the capability now to do it. So it's a small recap of what data science and big data really means. It is still applying the same scientific principles that were relevant in 1943, being inquisitive, being questioning, knowing that while you had an answer, it's always not necessarily, it's never 100% correct. There are all improvements, and data science is about constantly trying to improve, trying to study our data to glean more and more out of it. So that's my sort of principles and understanding of data science, and that's how we apply it here, certainly in the teams that I work with in the past and I work with today. Now, on top of that, we have the visualization element. I hinted about it, that my roots are in maps and geography. That's what I do a lot of at booking.com. And visualization is incredibly important for our understanding of data and data science, and helping us to understand initial cuts of the data, but also to form conclusions about what it all means. And it goes back to our earliest written attempts or earliest attempts to communicate. The earliest maps are 16,000 years old, and they were scratched or painted on the walls of caves. And before we had the written word, again, we were scratching and painting things on walls. We were trying to attempt to visualize our world, to be able to transmit information. Clearly not so much analysis going on this stage, but our very earliest attempts, they're all visual. We're trying to transmit or convey meaning to people and get that across. And that's fundamental to why visualization is the key part of data science. And if the classic, this is a great example, which is often quoted and often shown, it's the Nightingale Rose, where taking different data, bringing them together in analysis, and being able to visualize it helped them to convey the message of needless deaths. The classic case of huge amounts of mortality because preventable diseases, preventable illnesses were not being addressed in field hospitals in the East. And this is a great example of where they managed to pull together data through discussion, through conversation, through analysis between different groups, and then present it visually and had a fundamental impact at reducing huge numbers of unnecessary deaths in wars. So this is why visualization is the key part. And if you are trying to produce consumer-facing applications, which I do, most modern websites are dynamic representations of data. It is visualizing data in certain ways so that you can help people find the right information, or perform the right action, or perform that easily, perform it faster. All these are factors which are either going to help your product stand out from the others, or in fact increase your revenue. A classic thing is if the page is unresponsive, or if a person can't find the right answer, say within 3 or 5 seconds of looking at a website, they disappear. So being able to optimize your websites based on the data about how your customers use it is really, really going to drive increased conversions, or more visitors to your site, or ultimately be the life and death of your product. So it's very, very serious. Excuse me. So I'm going to kind of go through a lot of lessons I've learned visualizing data. I'm very new at Booking.com, so while there is stuff we are doing here, that obviously a lot of the examples are going to kind of go back through what I've done with other teams, and I've been fortunate to work with incredibly talented teams in the past. So I'm going to share their work, and it would be wrong of me to claim it's my work. This is the output of different teams and companies I've been with. So I'm just going to talk you through some of these. Several years ago now, I was part of a startup called EtoWorld, aggregating huge quantities of mapping and transport data. And we were asked, as the launch of data.gov.uk, to visualize some of the open data sets which are now freely available, but just a few short years ago, these foundational data sets weren't freely available to the public. To help attract attention to the cause, get people interested, we were asked to be one of these flagship sort of projects with data.gov.uk. So I'm just going to talk you through this as a practical example to highlight, again, one sort of founding principle. This is transport data. We were interested in telling a story. And again, this thing about data science is about discovering stories in data and being able to transmit them to people. So as well as being able to do it visually, there's this element of storytelling which a great data scientist will be able to create a narrative around data and be able to interpret and get people to understand and ultimately make decisions or affect outcomes. And we were very interested in congestion charging zone in London because it's this huge transport project. Nobody could really, if you ask the average person, or real people as I like to call them, they just kind of know it's there, but nobody would be able to tell you if it was a good or a bad impact, unless, of course, it was somebody who was driving into central London and now had to pay money to do it. You often only get negative stories. So this is looking at count data, cars and taxis within London, and you can see that we've tried to keep this as a very, very simple representation. But if you look at the top left, 2001, grey is base, which means no change. Red is a negative, and blue is a positive. There's various scale up and down. And what you should be able to see quite quickly from scanning from left to right is that it's gradually going red. And this is a good thing. The red means there's been a reduction in cars and taxis between 2001 and 2008, of which congestion charging zone was a big factor. It's not entirely the one factor, but it does play a big part. And again, here's a slightly more clear version of 2008. One of the hypotheses, or one of the statements about the congestion charging zone before it came into effect, was that it would only affect traffic within central London. And in fact, it might increase it outside. But what you can see here, apart from in the east, where there's been a lot of corridor development, which might have increased, shall we say, east to west traffic along there, you can see red dots all over London. So we've actually seen a huge decrease, really, really big numbers if you look at the south of the congestion charging zone. Really, really big decrease in the amount of traffic across London, which is generally perceived to be a good thing. Traffic will move faster if you do have to make trips, and otherwise you've got less congestion, less noise, less pollution. Pretty profound impact actually on what's happened and the shape of London and where it's going to be in the future. And we haven't managed to replicate that in other cities, but this is a great little visualization which was picked up by The Guardian, and there's various other media outlets who published it as well. Flip side, you'll note that we've actually tried to keep this very bold as well. In this case, we've got a lot of bright blue coming through, and this is bicycles. So the flip side to that is that actually there's been a huge step change in London, which is now being recognised, and you can start to see much more policy coming into place about providing safe cycling routes, that actually London has managed to achieve the step change. From a small base, there has been a large increase in the amount of cycling in London, which is starting to, again, to change the way that planners and other people have to think about building the City of London. It's a very important change. And you can see we're trying to make this very clear by almost in a pop art inspired style. Bright blues, bright reds popping out of the page, but very simple dots. And we succeeded in getting that out in quite a few media outlets, and it was universally well received. We also note, and I want to say this is the key principle that you should take away from this, that the first point of data visualization, or the first point of trying to use some data is, the first question you should ask yourself is, what shouldn't I be showing? Typically you're overwhelmed with huge amounts of data set. First question is, what can I remove? What is unnecessary to show? And if you look closely at the mapping style and the cartography, there is a huge amount of detail there in the background, but we've deliberately pulled all of that mapping data back. It's quite unusual to see black and grey mapping style. That was something which Hal, who is a great artist and developer, one of the people I worked with, this is a style he came up with, but there is great detail there, but it's all very subdued and in the background. So if you really wanted to look at it, you could say pick out main trunk roads around Streatham Hill or Clapham. But that's not what we want people looking at. We want them looking at the top data. That's really clear and popping in people's face in this great pop art style. And that was quite a big success. So take this away as think about what not to show and keep it ultimately as simple as possible when you are visualizing data for people. I'm going to try this next one. Let's just see if you can see this okay on your side. I'm probably going to skip it in a second, but this is a video visualization of traffic, flights over the EU. I'm not sure how well you guys are picking that up, so I'm just going to skip forward to a still. So we've gathered all this data, which was flights across Europe, and we showed essentially airspace over Europe shutting down as the ash cloud floated over Europe several years ago. And then as it came to life again, you could just see this huge burst of fireworks across the European sky, which looks like there's still all these flights crisscrossing over the EU. And this went viral. I think we had about 500,000 hits in the space of 12 or 24 hours. So it was a massive story. Got it out there. There was a few things that I wasn't quite happy with, and that's that we were attempting to give the story of there's a on there like there's a cumulative impact in terms of CO2, but almost because we created this quite beautiful artistic visualization, people focused on the wow factor. And if you read the comments and the people putting little notices on the various social media channels it was all cool, amazing, brilliant, this is fabulous. And it was a real attempt to kind of stimulate debate around air transport, and do we have too much? How do we protect people from noise? But by sheer the form factor of showing a video, of showing a visualization which you could play, and was incredibly beautiful. Actually, if you are trying to message, it can actually be quite unhelpful because people will tend to focus on the aesthetic, or tend to get distracted by how pretty it is, in fact. So that was just a little lesson. But you can find all this stuff on Vimeo. If you go to Vimeo and search for ITO World, you'll be able to see those visualizations there, and they look fabulous. And they continue to produce great work today. Another piece of work we were very interested in was we were visualizing OpenStreetMap a lot. And this was kind of a great learning lesson for us, and we produced these videos. Again, got a huge amount of interest within certain communities, which tended to be the technical world, people interested in how we visualized it or creation of this data. And OpenStreetMap is like Wikipedia for maps, so anybody can come online, they can edit it, they can put in data. But we did manage to achieve great success at sort of telling this as a story. Again, I'm just going to skip onto the stills. When we were asked to do some work for Tim Berners-Lee, and Tim Berners-Lee was doing a TED talk, very important, talking about great things, and they asked said, do you have a story? And I said, well, yeah, we do have a story, and this was the one we decided to show, and this is the visualization we created. Back in 2010 in January in Haiti, there was a huge earthquake, and just like it's going on now in the Philippines after the typhoon, aid and rescue agencies arrived, but the quality of the local mapping was either 30 years out of date or very poor, or the fact that half of the city had now been destroyed meant that you couldn't use the mapping on the ground. So we created a visualization, which was shown by Sir Tim, showing the evolution, the real-time evolution of a map, and everybody around the world was able to contribute to OpenStreetMap to build up a map with these online collaborative tools, using up-to-date satellite imagery to create roads, very up-to-date satellite imagery. In this case, where you can see the blue outlines, these are where people have entered refugee camps or displaced people camps. And people were updating and editing the map in real time. People on the ground were able to update and edit it. And it was used by rescue and aid agencies. And the thing which helped us to propel this story, if you like, beyond this visualization and into people's hearts and minds, and really get this out there, in conjunction with the visualization, was this. We were able to connect the human discussion, how people think about data and incident, with just this one image, which was a rescue agency on the ground in Haiti looking at a GPS unit with the data from this map. And that this is this huge, profound impact in the way people thought about it and transmitted this story. We, of course, were on TED, lovely, but we were able to transcend that, get into publications like The Guardian and even the BBC News. This story, really, really picked up, and that taught me a lot about how to transmit information to people, to turn something into people that people can actually talk about, have a conversation about, or just provide the information in a very, very simple way. The media is great at that. If you look at the way the Daily Mail, Telegraph, The Guardian, look at the way they tailor their messages, tailor information to their audience. They're very, very smart at turning what you could see as data into something that their audience will pick up and understand. And some of the lessons learned in visualization through working through these agencies were almost at all times keep it as simple as possible. I can remember producing, or the team produced, lovely maps of crime data, which you could see, funnily enough, where there's a lot of crime, where there's a lot of people. So funnily enough, crime is related to population. So the map in itself was quite interesting. It looked great, but actually there were instructions back to us were like, well, this is great, but actually we know that people really have a lot of interaction with top 10 lists. So as simple as having a top 10 list of the top crime-ridden streets around the UK, huge amount of conversation, comments piling in via social media, via the comment section on this this media website is you find a way that people can engage with data or read it very, very simply. If you can personalize it to them, by entering a postcode and then show what's going on top 10, people can very, very easily identify and talk about that data by keeping it very, very simple. And there is a great, shall we say, preoccupation around visualization, around new fields like data science, where we try and almost show off how clever and how pretty and how great we can do things. But the reality is keeping things as simple as possible with data visualization actually takes it out there to real people and gets the message beyond just, say, niche communities who are very, very interested in something. So I've been talking at will, so I'm just going to skip forward a little bit because I realise we are running short on time. To help me and to help the teams I work with and just sort of give us a structure for how we should turn data into insight, how we should turn data into visualization. And exactly the same principles apply to turning data into products. I just came up with 4 simple rules or a framework to create insight, to turn data into information that people can act on or can use or just simply understand. And these are keep it personalized, accessible, actionable, and instinctive. And instinctive, the last one is quite an interesting one, so I'll go into that one a little bit later. But personalized, very simple. If you're going to show any data, try and always make sure that it's absolutely relevant to the individual looking at it. If there's any way that you can segment them, any way that you know about them, anything you know about their previous browsing history or actions they've done, always keep data as personalized as you can. And that means simply if you can't show them something which is relevant, then don't show it at all. Always select the most relevant information for that individual or for that customer segmentation. Accessible. Don't flood people with data. Just constant drive for simplicity. And take it as well. Test this stuff. I can't emphasize enough how important testing the output of analysis of visualization is with real life people, because what you understand is accessible, what you understand is understandable, comes with a huge load of baggage and history with it. You've done years worth of statistics. Some of you probably work in computer science, or you're just very happy pushing numbers around in Excel spreadsheets. Having lived in that world and then having taken prototype products in front of real-life user testing and research, you would not believe how quickly people will just tear apart all your preconceptions and assumptions about what people understand or think about data. A classic thing I've seen is I've had one user testing session where we had 5 or 6 people, 80%, 5 out of the people tested asked us the question, what is a dashboard? That fundamental level of us bringing baggage from business intelligence, us having an interest in data, that simply using the word dashboard meant a lot of people rejected what was in front of them because they didn't even know what that meant. And why should they? Why should we believe that setting a science exam or a test for people is actually what people want? It's quite frankly not true. So test your stuff, keep it accessible, and it is just about the constant drive for simplicity in the presentation of data. And actionable as well. If you can't connect a piece of data with something that I can do with it, with an action I can perform, with something that is going to help me save money, which is something which is going to help me improve my life, or simply file this into my calendar, then you probably shouldn't be presenting that data at all. There are many instances when you combine insight of data with an action. It's by far the most powerful way of getting something done. Give people the solution. Don't just give them the data. And don't just give them insight and then give them solutions they can action it. And the last one, before I guess we're going to go to some questions, is instinctive. This comes from having worked with some behavioral scientists, and this is trying to look at the behavior and the context in which people are either examining the information or making a decision. You often find some quite surprising results. I've made products way back in the past 5 or 6 years ago by myself when I was just starting out, so creating data products, which I thought were incredibly interesting, very clever things with data. Could tell you this is where I work in London. This is all I can afford, and I'll show you all the areas in London and show you properties which are within my budget and within 40 minutes travel time, having crunched all this data. And of course, the output looks great, good visualization, good interface, lots of effort. But the end result was that very few people used it. And that's because I didn't understand the context in which people were making the decision to buy or rent a house. And if you actually have conversations, testing, do user research, that stuff, find that actually the starting place for most people when they are searching for a house online or trying to buy houses, they already know where they want to live. Most people have made that decision based on a huge amount of previous research, or simply they know the schools and areas where they live. The vast majority of people know where they already want to live, but they're interested in making that more detailed selection of, okay, this type of house versus this type of house, and I want to look at pictures of the gardens. So being able to do a transport-related commute search that just didn't fit into the context, didn't fit into the instinctive way that people are searching for or buying properties. Behavioral science can teach you an awful lot of interesting things about the way you present data. So previously in the past as well, we've been providing personalized insight. This previous company for energy consumers, people using energy. We analyze their data. So, you know, we've looked through your house. We know what your house kind of looks like. Da, da, da. If you did this, this is going to save you £120 per year by installing this, you know, kind of insulation, whatever. And you know, a very important thing we found through behavioral science and talking to researchers is that if you just change the word from save to waste, there is a much more profound impact of people actually reading it or following the advice. There's some kind of unique, well, perhaps not so unique, but Northern European behavior whereby people hate waste. If you tell people you can save £10 a month, they're like, oh, yeah, you know, might do it. If you tell people they're wasting money, huge increase in the amount of use, people reacting to it, because there's something about our character which makes us react to the fact that we're waste. We really don't like it. It might be some kind of, you know, Anglo-Saxon Protestant roots, I don't know, but it's certainly there. So understanding the context, the environment, and the human behavior around a decision, which I'm calling instinct here, is one of my key rules for insight as well. Now, because we're at 1:35, I think, I'm going to wrap up there and hand back to the hosts, who I think are going to field some questions.
Thank you very much. That was absolutely fascinating. As Chris mentioned, we do now have opportunity for questions. So if you'd like to type your questions, and then Chris will read them back and answer them. So we're just checking now to see if we've got any questions yet. Not got any questions as yet. We've got first question come up here, Chris. What tools are available off the shelf that do this amazing stuff? This is from Clive Crask.
Clive, okay. Off the shelf. So, yeah. So I've worked with teams where we have built huge amounts of our own technology and tried to, you know, build our own. And there are advantages to that. You can. A lot of the great, you know, incredible visualizations you saw were actually built with our own, you know, homemade, handcrafted technology. But it's obviously quite time-consuming and etc. etc. What I would recommend in terms of being able to do visualization, R is a great statistics. It's open source, and there's increasingly better visualization outputs from it. Processing is a JavaScript, again open source framework, which I've seen people produce very, very good high-quality outputs. So R and processing. If you're looking for more simple desktop, and both of those, by the way, are going to require you to get hands-on and dirty writing code. So if you're not comfortable with that, I actually am a big fan of Tableau software. I think Tableau is actually a very, very good desktop product. Being able to visualize and tell stories and stuff. I think they're doing really interesting things that you know, other software manufacturers are much further behind on that ability to visualize.
Okay, thanks, Chris. So we've got a second question. I'll just read this back. This is from Gagan Singh at Oracle, I think. He's asking, what are some of the big data applications in financial services analytics?
Anti-fraud, to throw out a glib one. Yeah, financial services. Well, look, they're without being an expert on financial services themselves. I do know that, you know, clearly there's a lot of people much cleverer than I am They tend to pick the best, working on very complex algorithms for huge amounts of trading at nanoseconds. A big traditional area of expertise within the financial sector is on fraud prevention. Very interesting work on how you detect what is possibly fraudulent transactions, being able to see, connect different types of behaviors which are possibly fraudulent as well. But I'm not an expert on financial services, I must admit.
Okay. Got another question, Chris. This is from Srinivasan. What's the website where we can see these visualizations?
Okay. If I type into the chat, will that show up for everybody? Is that going to work?
Yeah. I think that will.
Okay.
Right.
Give me 1 second then. Probably hear me typing. There we go. So I'm just going to paste that in there. So that's Vimeo, and I'll just put in one more link. So yes, the majority of the great visualizations you saw were for a previous startup as a member of called ESO World, and they are still doing great work today.
Perfect. And what we'll do, just in case anybody hasn't got the links there, we'll send, I mean from Unicom, we'll send these out afterwards to everybody by email. Okay, so another question. This is from Avinav Agaru. Can you please give an example for usage of big data in professional services environments and or for business to business?
I can. I'll make a note before I start. So business to business. Yeah, clearly I have focused on most visually appealing and consumer-facing applications here. The vast majority of data applications still have a business to business or internally within businesses. Excuse me. There's a wealth of data trapped within organizations. One of the concepts that I am, kind of evangelizing or constantly banging on about to whoever will let me do that for 10 minutes is the concept of a data-driven organization. And the fact that we have, very complex, very advanced ways of managing organizations which are global or large. But actually, if you look at the majority of decisions, they still come from anecdote, or they still come from a shared belief, and rather actually being tested data, being built on a firm degree of certainty. So, in Booking.com, for example, a decision doesn't get made unless there is significant quantities of data and analysis to back that up. As simple a change as an icon, or as simple as a change as some copy text. None of that happens within our organization without it being tested against huge numbers of people and having significant quantities of data to test it, which I think is a great, I'm sure we have huge amounts of data because we have huge amounts of people accessing our website. But within any organization, there is a huge wealth or troves of data. Some of it might be as simple as it's trapped in people's heads, and that a constant discussion process about how to analyze, how to even set the baseline matrix needs to take place. But this data-driven organization is a rarity, and I think there's great potential for people who understand the applications of data, who understand how their businesses work. They don't have to be data scientists. They don't have to have years worth of statistical experience like I kind of had the opportunity to do. But people who understand data, the applications, who understand their business, but are prepared to set up the structures, prepared to set up and get their hands dirty and say we need to understand how business works. We need to measure it with data. There's huge potential for people with those skills and the drive to get it out there in the modern world, especially, people are investing in big data. But how do you apply it within your own business, as well as selling it to other businesses? So I'm an exponent of this idea of the data-driven organization, and I believe it is still very, very rare today. Most business and organization decisions are based on instinct or supposition rather than actually being tested by data.
Thank you. We've got time for a couple more questions. I can just see another question from Clive, who actually asked the first question. What Clive is asking, how does Hadoop fit into the picture?
So Hadoop is basically a way of running MapReduce. So Hadoop is historically batch-oriented. There is lots of work going on with projects like Dremel or Dremel, which is focused more on the real time. But Hadoop is, at its simplest level, a file store, which makes it easy to store huge amounts of data in a particular format, but then the ability to batch it together and run massive operations across it, across, say, a distributed network, so you can perform what could have been a query which might have taken several weeks or a month on a computer across a huge number, and have it completed within a matter of minutes. So Hadoop is this kind of foundational technology of, one, being able to store huge quantities of data, but also being able to process it and pull the outputs together. It's not the solution. I hear a lot of people talking about Hadoop. Hadoop is the solution. Hadoop is one part of a toolkit, one part of a methodology of let's call big data or data science. And if your needs are processing huge real-time streams of data, then chances are that Hadoop is not actually going to solve those problems. But it would be great at storing previous vast quantities of data, but not for the real-time processing of it. So Hadoop is a functional part of it, but it's one part of the toolkit of big data. It requires a lot of understanding of how to store, analyze, how to measure stuff, what technologies are applicable for different use cases. So Hadoop forms a part of the picture for certain use cases, but as ever with any organization which is trying to define what they want or trying to define how they solve a problem, start with the problem. What are your use cases? If your use case is, I want to store huge quantities of server logs and run batch processes so that my analysts can then look into those batches in more detail, then yeah, Hadoop is a solution to that. But as ever, I'd say stick to describing the problem, and that's the way to identify what the solution is.
Thanks, Chris. We're getting near the end. We've got time, I think, just for one more question. There's actually quite a lot coming in. One question is from Gordon Dash. What is the current state of the art in predictive analytics compared with data visualization?
Predictive analytics is hard. That is very, very hard. Predictive analytics. Predicting is kind of a dangerous game to get into. I would say that my experience of prediction is by focusing very much on history, understanding trends, understanding the factors which could affect an outcome or a decision. But prediction, state of the art, is very much based on a firm understanding of the past and the decision points and the actions that might be taken to influence that prediction or influence that outcome. But prediction is a tricky and risky game. It's not my area of expertise, I have to say. But its foundations and its roots are based on understanding trends of the past. if that gives you any help.
Thanks, Chris. I think we're pretty much out of time, so I just firstly want to apologise if we haven't answered everybody's question. We've had an awful lot of questions, so we've been taking them in the order that they've come in. So it's very encouraging. There's so much interest. It's I think an excellent presentation. As I mentioned earlier, Chris will be presenting at the conference in London on 5th of December, Big Data in the Context of Financial Analytics and Social Media. And on that day, there'll be a lot of other related presentations, really digging in deep. Along with that, there'll also be panel sessions, opportunity for question and discussion. In fact, also going back to Clive's question earlier about Hadoop, we've got running in parallel to that conference a second event about adopting open source as part of the organisation's IT strategy. So there'll be some really interesting discussions going on. You will be able to go into sessions from that event also. Just one final point to mention. We also have another webinar tomorrow, just again picking up on the open source point. We have a webinar called Introduction to Open Source Governance and Compliance. That's at 2 to 2:45 tomorrow. If you want to join it, just send an email to us. Probably the best email address is info@unicom.uk, and we'll just email you straight back with a link. So all it really remains to say is thank you very much indeed to Chris for presenting such an enthralling webinar today, and for all of you for joining. Thank you.